I don't know who all has the Linux Academy login, or who all um, has the ability to who has the book, the RHCSA book. And let me pull that up so you know exactly what I'm talking about. It should be on Amazon. Should be a new one coming out. So in particular, I know a lot of people probably follow um, this particular book here, or this particular book, and then there's also the LPIC book. I spelled book wrong, but it's okay. So there's the LPIC, the CompTIA LPIC, the Linux Plus book, and then there is the RHCSA book. The LPIC kind of covers Ubuntu and CentOS based or Fedora based OS. And we can go over some stuff here. All right. So let's go to courses. Let's go to Linux. And in a minute, I get to while we're choosing, I want to show you some stuff out of on Google Cloud. All right. So if we look at this syllabus here, let's scroll through the boot process, power up system D and upstart, meaning Ubuntu and Fedora based. And talking about system objects, this sysinit V was what we transitioned to from Rail 6 to Rail 7. Boot targets. Then they go through some hands-on labs and some exercises. Then they talk about LVM, which is common between both Linux platforms or both Linux OS. Hard disk layout, boot managers, and then they talk about Debian packages, which would be your Ubuntu based, and then the Yum packages, which would be your CentOS based. Shared libraries exist on both. Then we get down here, we start talking about different commands, sort. We went over some of this too. Snort. There is a snort, but it's sort, cut, paste, join, unique, head, tail, set, format. We went over that. LSDD, remove, find. We went over those. Use streams. We didn't go over kill. We'll go over those next week. egrep, grep, vim, copy paste in vim, searching in vim, uh, word count, that was the WC. And then they start getting into partitions and disk quotas. Um, really, to be honest with you, like, okay, so like on the disk quota side, this is when this is going to come up. Disk quotas are going to come up when you are really dealing with an attachment, an NFS attachment, or so forth, and you got to do a disk quota. But for the most part, if you're in the cloud, you're not going to handle the quota at the level of the OS. You're going to handle the quota at the cloud level. So, give or take on that. But you probably needed to pass the test, but it's the same premise and the same concept. Um, Integrity of file systems, and then that's it, right? So let's go back over here and to show you a difference. Let's look at the RHCE, RHCSA. Let me see if I can find it. It's I think it's called 200. Yeah. All right. So here's where in both cases, this is where you can use Google Cloud or Amazon Cloud, or you can use a Vagrant Box or what have you. I'm just trying to give you alternatives that you can do. So in here, same thing, input, output, how to SSH, how to use the locate command, so forth and so on, priorities and so forth. But here, now we're talking about how to access a VM and how to start up VMs and so forth, right? So really what they wanted you to have was a bare metal machine and do startup VMs on your bare metal machine. with using KVM, and then using the virsh command in order to uh, start up your VM, and then do whatever you need to with virsh. So inside of Google Cloud, you could do. I had the link. It's called what is it called? Yeah, nested virtualization. And I think next week, what I'm gonna try to do is I want to run through everything here, and then I want to get into how we can create partitions and um, use KVM and all of that. Basically, what I've been showing you is this entire class for what we've been doing. I've been showing you this entire class, just taking out parts that I know we can get away with real quick. But now we're at the critical point where we need to um, get down to, using KVM. And after you start doing KVM and SE Linux, that's the gist of the class. SE Linux and file permissions. That's the gist of this RHCSA class, and you can from there go on and take the exam. Yeah, I mean, I would run through this, but here they talk about how to set up nested VMs, and I give you this. You don't have to do this if you have a bare metal machine where you can do this on. But if you have access to a Google Cloud or AWS Cloud and you want to play around with this, it'll really help you out understanding how hypervisors work and understanding how virtualization works and so forth. So that's what we will be doing. So tonight I actually spun up an instance on Google Cloud and logged into the instance. What I do like about Google Cloud is, and same thing with same thing with AWS. You can log in. You can use their terminal and log in and go from there. So let me see. Do I have one? I'm on the wrong one. Let me go to my account and console. All right, so just a quick, brief overview of Google Cloud. You have what they call Cloud Launcher. I'll click on that. So suppose I want to just stand up a WordPress site real quick, or I want to stand up, you know, I want to test how to use Nginx, or I want to do Kubernetes or whatever. I just click on it, spin it up, keep it moving. Remember that when you use Windows or a Red Hat, you're subject to pay for a license. So just something to keep in mind. Um, Back over here, we got my billing. I got my supports, my APIs. I can use different APIs. Like I got different APIs I can access, and I have to give myself uh, permissions to. Um, your identity, and then this right here is when you start getting to App Engine. Compute Engine would be equivalent to AWS EC2 containers. Kubernetes, if I want to build out a cluster, it usually builds out just a 3-node cluster. And then if I want to build out a storage, I can build that out. We'll get into that too. Then here's when we got the different types of storage, and then networking, and then we got firewalls, and also when we want to start doing tracing and logging information. That's what we have here. And then this gets into your big data stuff with Dataproc, native stuff, BigQuery, uploading. They have tutorials that'll walk you through all of this. So just like a brief overview here of what you can do with Google Cloud. But today I installed CentOS. I spun up a box of CentOS 7. You can see it has 10 gigs of 10 gigs in size. Let's look at if I do a LS CPU. Um, you'll see I got my one CPU. I'm small. If I clear, if I do a free dash G, I have a total of 3 gigs in memory. All right. So that's just a little quick view. But um, I'm going to also show you there is a command that I use to log in. You have to exchange your SSH keys, but here it is: G Cloud Compute, the project that I'm in, the zone. It'll give you this, and then you log in. Once you get logged in, I sudo up to root because I just want it to be root, and there you have it. I'm in. Pretty simple. All right, so let's get back to uh, some stuff that in this Linux Academy class that I wanted to really point out. Let me see, KVM. Uh, so here we go. Yeah. So start and stop virtual machines. Please don't start. But that's what they're talking about here. So yeah, starting and stopping virtual machines. Also, another thing, we want to be able to build virtual machines. So inside of Google Cloud, what they have is we basically create the image, and then based upon the image, we build our virtualized server off of that image. If you were doing this on bare metal, you would download an ISO, same premise, download an ISO and then boot up off the ISO, or you can kickstart off that ISO. Any questions so far? Anybody lost? All right. All right. So we're gonna start training here in about 5 minutes. Well, I want to go over this as well too. So this book is called System Performance, Enterprise Cloud Architecture. Let me see if I can go to the. Let's get a look at the book. All right. Why am I showing you this? I'm showing you this for a couple of reasons. It's an older book, but in most of the interviews that I've been on, is from Linux administration to cloud architecture to site reliability engineer. You need to know how things perform and how to troubleshoot those things. So I really want us to get past the Linux stuff, like the virtualization piece and all the commands and stuff, and start trying to go down the performance guide and understanding things. Let me see if I can find um, that uh, that book or the website. I've had it up here before, but I think it's really important for us to understand this. This is the same guy that wrote this book, but I want to look at it from this perspective. Like, you see here where it's got the application level, application troubleshooting. That's important because a lot of people ask you, how do you troubleshoot an application? How do you troubleshoot a database? How do you troubleshoot memory? What is memory mapping? How do you look at a system in real time? And I went over this before when I did a cat proc. Uh, you can do cat proc CPU info. Remember, I did a LS. I did a LS CPU. LS CPU. You see, those things are the same, but this is your real time here in this directory /proc. This is your real time system where you're getting this stats and so forth and so on. If I type uptime, let me cat proc. Even though I'm in the directory, I just want to show you that uptime. All right, you see the difference here? You see how it's changed? So that uptime, actually uptime is probably reading this and it's formatted over. So let's look at which uptime. If you ever want to know where something came from, you can do which uptime. It's in the path. And then I can do something like yum, what provides bin uptime. And so it went through and it says that it's coming from this package here. So that package installs this script, uptime script. I'm sure I can't, it's in bin. I'm sure I can't read that. Yeah, I figure I won't be able to read that. I can't read the binary. So install that binary. But back to this. I want us to, where did it go? Oh, here it is. I want us to be able to go through all of these commands, every last one of them. And you're probably going to need to take notes, and you're probably going to need to um, play with these commands. But these commands are going to be important. When you see this scheduler here, understanding in this book, they actually talk about the scheduler. Let's continue reading. And there's 3 different schedulers. But I want you all to be familiar with this information and this stuff because um, this is what they're going to ask you in interviews. This is what they're going to ask you when you're uh, uh, maybe doing a technical interview overall. Yeah. Which link? Let me go back here. This one. Here, I give you this. And also, look up Brendan Gregg on YouTube. He breaks a lot of things down. And let me get the book. Um, mm, mm. Here's the name of the book. Well, forget the logo part, but systems, performance, enterprise, and cloud. All right. So let me show you something in here that that stuck out to me. And I think he has exercises in this one too. And I may be getting this confused with another book, but this book's still good. All right. So like in here, he's showing you, what is like an interview question. I'm gonna give you some homework, or you can do this in class. What is virtual memory? All right. I give you all a chance to look that up. Um, and then I'll let one of you respond. This is the way you learn. And then you explain it to me or what you think it is or what you found and post a link of where you found it at. And I'm just kind of going over some brief overview of stuff that I've seen in here. Um, how do you, how to find load average on a Linux box. Yeah. And what affects load average. Now I give you a quick answer. So if I did top on my box, you'll see up here I'll find load average. And remember what I said before. The first one is what the process is waiting on to get executed on the system in the first minute, in the next 5 minutes, and then in the next 15 minutes. What did that look like? Another thing is like being able to break top down. And all this deals with performance. I'll post this and you can get into more detail. All right, we have an answer. Here we have an answer that says a computer can address more memory than the amount physically installed in the system. This extra memory is actually called virtual memory and is a section of the disk that's set up to emulate the computer's RAM. All right, so now let's click on that link that you gave. Let's see if they have a diagram. Yep, they have a diagram. Let's look at that diagram. And if you all think this is advanced, it's not. This is just understanding performance and commands and what these commands are doing and so forth. And I think if you take the time to understand the commands and understand how the systems work, by the time you start installing and playing with operating systems and doing everything else, you'll be well ahead of everything. So here's where the virtual memory is. So I give you some background on this. So in here we see these are the registers. So if we break down the computer itself, we have memory that we address. This is our physical memory that we address. Like we can actually place stuff onto the stack, and the stack will be here. And then we have that secondary memory, like it says, that's on the hard drive here. And it addresses these elements here. So read over this page it'll be informative, but I want to discuss this in our Slack so we all have some contents and stuff like that so that we can all keep up with this information. All right. So another thing, like I said, is top is like how to find out, what the load average is and what top is telling you. As you can see, let me get my page here. We can break this down some. All right, you can see we got the current system time, which my time is wrong. We got the number of days it's been up. For me, it's only been up an hour. We have how many users are on here. That load average, as you can see, like I said before, the first minute load, the last 5 minutes, and then the 15 minutes. And then they break down row 2. You see the US is the user process, the SY the system process, the NI, what they're calling here is the nice value, the IDs, the idle state, and then here they're waiting for IOWA. And HI is the hardware interrupt. So, in other words, when a piece of hardware is actually interrupting the process or waiting to be executed on the stack, that's what they're talking about there. And then the CPU, software interrupt, and then stealing time, like something is stealing the time. And then they talk about what those are. And then they break down the CPU utilization. Right here is where it goes here. And then they go into memory as well too. So I posted this link. I want you all to be familiar with that. You should be able to break all of that down. They're just questions that people ask. And then here's some commands that you can play with here when you're playing with when you have top up. So let's do Shift A. All right. So now Shift A was the process ID. So now I'm ordered in process ID, and you see also broke it up into different 4 different categories here. And then it also looks like see, this is the root user. I don't see a user here. Let's go back. Let's do B. Let's see. Let's quit that top and let's do B. Did you? Okay, you saw that. So top, the parent process ID, the PPID is sorted by PPID. I'm going to quit here. I'm going to go back to do top. and I'm going to do a D. It should be shortened by user ID, which is the second column. Change from 3. Oh, change delay. Oh, let's see if how old this one is. This may be an older version of top. Let's see. Can I change that? Let's go back. Let's quit. Let's see if that's changed. Because I was supposed to be able to do a D, and it should have sorted by user ID, but it didn't. Okay, so now delete D is delayed time versus over here user ID was something else. And that's a lowercase d. So it changed. So look at do a man on top and then look at look at what you have. So here, if I want to sort by PID, I should be able to sort by PID or user. Yeah. Show any, okay, yeah. Lowercase u, capital U. And then you can pass parameter, like these parameters you can pass when you're doing top. So instead of just top, you can do top dash, whatever. So I could do a top for the user or the name or the number. So let's look at this. Top dash U root. All right, so you can see here, this is all the processes ran by that particular user called root. And it shows me everything about that particular user. So just some things to be wary of when you're playing around with top. A little bit more in depth than what we did before. We're going to probably revisit this again next week. But next week, I want to try to get us on to setting up stuff with the KVM so we can install our OS. Because I don't think most of you have seen an OS install and how we can automate that process. All right. So let's go back over to this guy. And then let's look at this thing here called networking. All right. So on most of these Linux systems, everything is in etc for CentOS. It's etc sysconfig network dash scripts. If I do an ls, you'll see that I have a lot of scripts here. And remember, before I can do an ls minus capital F. All right. The star lets me know that it's a script, a binary. The @ lets me know that they're links, and they're links to something else. But if you notice that this doesn't have anything, that's because it's a file. So let's look at that file. All right. I should change this color. I don't know. Let's see. Make it bigger. Can you see that now? Was it still hard to see? All right. So in you'll see the DHCP name. When I spun this instance up, it gave it localhost. The boot proto is what protocol are you gonna run over DHCP. I can change that to static or none. It's telling me the device name is ETH0. And should this on boot, should we start this up on boot? You say yes. And then it gives it a UUID. And then the MTU is the number of frames. And then persistent DHCP client, yes. All right, but there's other parameters. So we can do yum what provides let's see if it give me that. Yeah. All right. So it's telling me init scripts gives me that information. So that's something, that's a package that gets installed. What we really want to know is what are our options for configuring the interface. So let's do a man on network and maybe something else. I may have to look it up. Yeah. It probably won't let me. Yeah. So I'm going to have to look that up. Let's see what We can do see networking Linux config file. Let's see. It may be in the doc. All right, so here is. All right, are they gonna break it down? No. Okay, here's a little better. All right, so when configuring interfaces, all right, remember before you give it a device. Now, let's talk about this. So in Rail 6, the device naming scheme was IFCFG ETH0. This is a Rail 7 box, but because I'm on Google Cloud, they probably have some script that keeps it the same to say that it's ETH0. But really in Rail 7, they come out like IFCFG dash something like PMO124 or something like that. They get this real funky naming scheme, but you can change that naming scheme um, with your UDEV rules. So let me show you that. Yep, it's usually etc UDEV. Um, let's look at this. This is something pertaining to their stuff. Let's look and see what they have. That's not a file. Oh, it goes to /dev null. Oh, awesome. Let's look at this. All right. So in here, and it'd be similar. The network configuration would be similar. This is like getting in the weeds, but I just want to show you this that you can control some of the naming schema that you have. In terms of like if it's a SD or a VD, they have this naming scheme that you have. So what they're talking about here, if I did a cat etc fs tab, right now it's defined by a block ID, and I can get that from doing this command. But you can see that, remember in that file that had SDA or SD star, and so SDA gets this, and then it's labeled with this UUID, and then the type of file system is XFS. So when you go into here, you'll see this UUID matches here. The label that is matched up with is here. The file system that is matched up with is here. And then it tells you uh, the defaults and then 00. Like, and we'll talk about that, how to break down FS tab. So that's getting into the weeds, but that's how the naming convention and schema gets on default when it boots up. It looks inside of that. It looks inside of this directory for the UDEV rules in order for networking, in order for your naming schema for your drives and anything else that you may set up in here that you want to mount as under a certain name. You would come here and do that. So that's how that works. All right. And then back over here in that file, these are some of the things that you can put inside that file, right? But there's more things like you can put, if you want to, like, see they had the boot proto, DHCP or none. You can also set up bonding. You can set the broadcast, the device name. If you want that interface to have a particular DNS rules. Like, hey, I want this interface to have this DNS IP address. Like, I want it to resolve to these things, to this DNS server. You can do that. You can set up the gateway, the hardware address, the IP address. You can give it a static IP address, a MAC address. You can change the MAC address. The master bond is like for when you're bonding, and we'll talk about that. The net mask is your net mask, or your subnet that you're going to be on, whether it's on boot. Should this device be activated on boot or not? Pure DNS. Should this be a slave? And user control. Answer the following: non-root user allowed to control this device? Yes or no? So we could go back to our file, sysconfig network scripts and IFCFG ETH0, and we gave that DHCP host name, that boot proto, we know it's DHCP, the device name, we're going to call that on boot. That UUID is generated, a did block ID. I need to find out how do you get the UUID of the network, and then persistent DHCP. So you can probably look up versions of Rails 7 to find out, what other parameters you can set. This right here is an older version here. I think this is probably Rails 5, probably. Yeah, this is 5. I can tell about the documentation. And up here. Yeah. But it gave you an idea. Let me go to CentOS 7 IFCFG ET0. Oh, that's still 5. Uh, this will work, but it probably won't break it all the way down. But yeah, it just gives you like, hey, I want to set up static, the prefix, the IP address, and system control restart. And then if I want to list network interfaces, IP-A. And then you can also set it up using the command line tool, NMCLI, and it gives you like the devices. So we could try that too. And as you can see, I only got the ETA0 and the interface, the localhost interface, and I can double verify that by going over to etc sysconfig network dash scripts, and then if I do ls, you'll see the only two devices that I have are that ETA0 and local interface. So those are things of how to set stuff up, how to troubleshoot them, looking for information, again, setting up DNS servers, the default route, yes, and how to find a default route IP or route. You can see what the default route is going out of, and so forth, or default interface. I can also check if I do a cat on etcresolve.conf. If I haven't set my DNS in here, my DNS gets set inside of here. This is actually a bad name server right here. It may be. Oh, yum install bind utils. I just know that's where host is at. I could do an NS lookup, but bind utils takes care of host. So now when I go back and do host, it's telling me that, yeah, so pointer to metadata.google internal. If I did host 8.8.8.8, those are Google servers. You'll see Google public, and 8. I think it's 8.4 or maybe 8.44. Yeah, another set of Google A and B servers, NFS servers. Shania, I saw you had posted some stuff here. All right. Low average tries to measure the number of active processes at any time running on the CPU. High low averages usually mean the system is being used heavily and the response is correspondingly slow. High means high enough that you don't need uptime to tell you the system is overloaded. So lots of active processes, basically, yes. But what's causing those active processes? Is it just spinning? This is where you get into is if you start running a application, is the application just spinning out of control? Excuse me, are there memory leaks, and being able to troubleshoot and break that application down and to find out what's going on with it. So that's very important when it comes to troubleshooting. Let's go back over here. Um, so another question that comes up is what is a file system? And how do you find the type of file system you are on? So I'll let you find out what a file system is. Anybody else can answer that question, post it, or what have you. You find out what a file system is. Now, why is all this stuff also important? If you're doing anything in security, this is all this applies as well to understanding what a file system is, to understanding how to secure your file system, how to secure services, how to ensure that a system isn't sending out wrong information. That stuff is important. So, how do we know what file system we're on? Well, we can do a couple of things. We can do a Fdisk L. All right. And in here, you'll see I have like this 83. I think 83 now is, it says DOS, but that's so wrong. It's not DOS. So let's do this. Let's do fdisk/dev sda. All right. And then let me actually clear this. Clear. All right, so I can type M, and M's gonna tell me like different commands I can run. So if I wanted to edit my file system, if I want to print my file system, well, my partition table, if I want to change it, I can do all of that. So let's quit here, clear, and then let's print. So in here, it's actually telling me that the list label is DOS, and then it says it has an ID of 83. That's not true. So let's type M, sorry. And then if I do an L, it'll give me a list of known partitions. So I'm gonna clear this out again so we can get back up to the top of the page. And I'm gonna do L. All right, then now this is old school. This is actually older. Uh, if you install Linux right now by default, you are probably just, if you take all the basics, you're gonna get LVM partition, which will be an AE. Here it says it's 83, right? But really, what it is the our file system is XFS. It's been formatted that way. And I know that for a few things. When I look at FS tab, I see that XFS is the format, right? Well, when I looked at it, it said DOS, right? When I looked at the partition, it said my root partition was DOS, and I'll go show you that again and print. It's telling me, oh, let's do this. It's clear. Let's do fdisk on SDA1, and then let's print. See, still telling me that it's DOS, right? But what I do get is I do get the fact that I have a partition, which means that's a good thing. It's finding my partition. When I print this, it's telling me that I have SDA on all the cylinders and all the sectors on that particular one. So let's look at uh, how to find file system, and I'm sure in proc it should tell me. And I'm going to go over there right after I run this command. All right, let's quit here. Let's cat/proc, and that should be file systems. All right, so I see XFS. It says no device here. So let's look up proc file systems and see what they really are saying to us. Let's see. All right. So it looks like, from what I'm reading, is anytime there's the blank, that's actually turned on, meaning that this file system has ext2 and ext3. It says the first column whether the file system is mounted on a block device. Those beginning with no dev are not mounted on a device. The second column lists the names of the file systems supported. So if we're looking at this and we do a cat proc file system, it's telling us that we didn't find anything here, but we sure did find XFS. So I just showed you two ways to find whether or not that file system is XFS or not, right? So we verify that it's XFS from two locations. Any questions? All right, what I'm seeing when it comes to what a file system is, it depends on how we're using it. It can have multiple definitions. The Linux directory, uh, the Linux directory, hold on, okay, the Linux directory structure starting at the top, root file system, the data storage format such as ext3, ext4, BTRFS. By the way, BTRFS has been retired from Red Hat. They're not going to fool with that anymore. XFS is what they're focusing on. Linux supports 100 types of file systems. Yes, it does. And old ones, a partition or a logical model formatted with a specific type of file system that can be mounted with. All right. So the other thing, okay, let's look at what an actual file system is. Let's go back to our book, right? All right. So when studying application input, the performance of the file system matters more than the disk performance. File systems use caching, buffering, asynchronous output to avoid subjecting applications to disk level latency. In other words, I don't want to run it on the disk itself. Like I don't want the swapping to occur, or I'm running on a slow disk. All right, so let's look and see if they break down the file system. All right, so background introduces file system related terminology, basic models, illustrating file system principles, and key file system performance concepts. All right, let's see. File system, an organization of data as files and directories with a file-based interface for accessing them and file permissions to control access. Additional content may include special file types for devices, sockets, and pipes, and metadata including file system access. So I'm going to cut and paste this because all of this is what you would want to know. And if you can put this into a terminology or file system thing and go from there, you want to know this stuff. You can break it up however you want to there, but I think it came over pretty clear there, right? So this is what someone will ask you on an interview. what a file system is, and being able to break that down and understanding, like, what affects the file system, how you can troubleshoot the file system, is important as well too. And that's why we're going to do the install of the KVM, so we can do inspections on the file systems, because there's a difference on troubleshooting XFS file system versus ext4 file system, right? And then they get into like the basic model of the file system. Like, remember, these are just functions. Like, somebody wrote a C level, a low level function for reading, writing, and seeking, and linking and unlinking, and so forth. And you can see here that all that falls on the application side. And then you can see here on the system tool side, this all falls on the mount side. And then you got your storage disk. I really like this book. I don't know. What do you guys think so far about this book as a reference? I think it's a really good. I think everyone should go through this book. Right. So then they talk about yeah, they have exercises at the end of the chapter. Then they talk about, read requests and so forth. Like, I think, this is where you start, like, anyone who's going in here to be a site reliability engineer, like, understanding these concepts are really going to help you out. And if you get on a team where you're doing troubleshooting for an application or something of that nature, this is where that book comes into play, in that website as well too. All right. Any questions? All right. So let's go over here and let's look at disk. But let's also go back here and look at the image. Let's see. Where's that image at? Let me scroll up. I should get the image from me posting. Can't find it right now. What do I do with it? Hold on, let me find this image. System perf book. No, that's the one we're going through now. Where is that image at? I don't see it. Do. No. Alright. Performance. Application. Performance. Tools. That's not what I want. Let's go here. I may be spelling his name wrong. Alright. But anyway, I wanted to show you that book. The disc. Let's move on. It'll come back to me. Let me find it. Let me scroll down here. All right, so disk. All right, so the different type of disk also play into a factor of the application performance. It also plays into a factor of the database performance as well too. Especially when you start talking about, um, and Giselle can tell you this, whether or not you've rated the actual disk in a way that provides the best performance. Um, and so that gets into IOPs, and this is a bare metal situation, a cloud situation. Pick a cloud, and also if you're doing your using KVM situation as well too, and a SAN situation. So there is a book. It's free. I highly recommend it. I think it's called Information Systems, and I think it's by EMC. You can download this book for free, and I have it on my shelf. That's not it. Let me look it up. Information systems. Let me see, book. I think that's what it's called. Yeah, information storage. Yeah. So you can download this book out here on the internet for free. But in this book, it really breaks down how to calculate IOPs. And I've never seen, well, it's probably some out there, but I haven't seen anything that really breaks down really how to calculate IOPS. And as you can see here, it's pretty thorough here. That's just a community version, but that's not the book itself. Let's see, here's the PDF. It's an older book, but I recommend this book for understanding how to calculate IOPS. I also encourage you to look up different disk types. All right. So there are different disk types and different RAID types. Let's go and see what this book has to say. If they really going, so this book is 4 years old, so they may not go into. They may go into SSDs. Yeah, simple disk, caching disk, and have a disk controller. So here, this disk controller, this is when we start referring to SANs, and then the SAN partitions out these different disks, but you can have different disks inside of a SAN. So think of it like this: like when you go to the store and you buy your laptop, and your laptop could be 5,400 RPMs, or you can get one that's an SSD drive, or you can get one that's just a regular IDE drive, which is much slower because now you got spindles and you have a disk, and it has to go search the entire disk for information. Right, so it's always spinning and searching the disk. So that's a delay. That search is a delay. Versus solid state doesn't do that. So understanding like the different disk types from, and I'll type it here, solid state, um, IDE, and then there's also inside of a SAN, you can get different uh, disk types. But you know what? Since we are here, let's look at let's go over here to Google. Let's go to Google Cloud, and that's another way to let's look at different storage types. So I'm just gonna walk through. I'm not gonna launch it, but I'm just gonna show you what the different disks are that you get access to. Oh man, let me change different disks that you have access to, and then you can go from there. All right. So whenever you decide to render today, uh, sure, and inside here, I can launch an instance. So let's create an instance. And in here, you can see I could customize the number of cores I want, the memory, or I can select the GPU. But here, this is where I get a little bit more control, and I can change, and I can select different images. So here's my OS image, but I'll come down here and I get an SSD or standard persistent disk. And then these are based on different types that tell you here. Storage space is much expensive for standard persistent, but I don't go into details. Let's see if we click on learn more. All right, here we go. Right. So they go into tell you about the standard persistent disk and the solid persistent disk, and they tell you about the maximum size. Also, what you want to know as you continue to do these things, you want to know about your throughput, your write output, and so forth. So when you're uh, looking at an application that's performing slow and you start getting down to, is it the disk or is it the way, is it the route that it's taking, maybe a firewall issue, understanding how to troubleshoot that goes a long way. So in this book that I had pulled up, this one here, they actually talk about IOPS. I'll give you this link. You can download it. It's free. But they actually talk about information storage man. It's an old book, but it really goes into telling you about just storage in general. Let's see if it'll come. I may have to put capital IOPS. Still searching. All right. So here we go. So here, remember I told you application requirements and disk performance. This is what it gets into. And then back over here in this book here, remember we were talking about performance and disk. This is the same thing. How to measure input, output, service time, and certain commands are going to give you this information. So see on here on this cache flash memory, and then at the end of this, even though there's even though you had this information, he gives exercises on how to calculate stuff. Like what does IOStat actually give you, right? I don't think it's installed by default. I think I gotta find the package. Yum search IOStat. And then I gotta install the package. Yum install. Let's grab that package. All right. Let's clear. Let's do IOStat. And you can see, I got my reads, my writes, uh, read. I think this is read write in and out on that particular device. It's giving me my IO weight and so forth. But I can also do a IOStat um, dash H or dash dash help. That's no good. Let's do IOStat. Man on IOStat. All right. So here you can see I get different. It tells me about the different parameters. I mean the different things that it's reading in. But remember before it was like block read, uh, block read write, block read, in and out, uh, the number of merges, just different things, and then I can pass different parameters like how I want it to be displayed. If I want to get a CPU utilization report, I could pass these parameters and so forth. So, you know, just different things you could do with IOStat to give you that information, which they talk about in here, which also gets talked about in the book itself. And then, again, like I say, understanding how to calculate IOPS is important, and then um, understanding what the application needs. Right, so you may get a application and says it's been running fine all day, but then all of a sudden every day at 5 o'clock it gets this high load, and we don't know if it's freaking out because it's getting a high load or something else is on the system that it's with that's using the actual hard drive or the CPU. Understanding how to break that down and understanding what you're looking for and where to find all that information at. So that was actually pretty cool. Let's look in here. Sequential IO. Remember I told you about the rotational disk, the read write, IOPS. IOPs are not equal because of the latest 3 certificate IOPs are not created equal and cannot be directly compared between different devices and workloads. And IOPs value doesn't mean a lot on its own and can't be used to accurately compare workloads, for example. And they talk about this, but now you add in, you got a high memory, and then you're reading the IOPs. This is where it all comes together. So, just something to be on the lookout for. All right. And then last but not least, let's look at benchmarking. Why? So someone comes to you, right? And they say, hey, we want to build out this new application, and we got 30,000 users. There's probably going to be using this application. You know, what kind of hardware do we need to use? What kind of how do we set this up? What's going to be our best, not necessarily best practices, but what's going to give us the best results, the best performance. And a lot of people do a trade-off. A lot of people do a trade-off of performance versus security. And now a lot of people are going back to saying now we need the security piece. So you see this big push for sec DevOps or DevSecOps, or then you see this other big push for just like DevOps, and then we'll secure later. So it's a go back and forth in between. But in this book, they talk about capacity planning. They talk about benchmarking. Oh, and the other link I want to give you as well, that goes hand in hand, is the Linux Performance Guide from Red Hat. I would totally be focusing on these three things if I were you all. Once you get, the cloud information in your system, and once you get to understanding how deployments work, this is going to help you out a whole lot. Just reading this for a whole week straight, go through every single command, like spend a whole day on one chapter, and go and knock it out. Like if you spend 3 hours, like, look, see, performance monitoring tools, tuna, CPU, memory, networking, and then they break down, all this information here. But all that is also in combination of how to do benchmarking and how to uh, do a performance analysis of, your stuff and what's coming up next. So, is there any questions from anyone on this stuff?